Good evening, students. Tonight I will be conducting a lesson that is in regards to recognizing areas and attributive plane figures and understanding concepts of area measurements. Okay, by Miss Victoria Santana. Me. Okay. So first we will start off by studying some California Common Core state standards. So we have 3.MD-5, which is recognizing area as an attribute of plane figures and understanding concepts of area measurements. And then we have 3.MD-6, which is measuring areas by counting unit squares, which is square centimeters, meters, inches, feet, and other units. And then 3.MD-7A through C is relating area to the operations of multiplication and addition. So A, we're finding the area of a rectangle with whole number side lengths and showing the area is the same as what we found by multiplying the side lengths. B, multiplying side lengths to find areas of rectangles with whole number side lengths. C is using tiling to show that area of a rectangle with whole number side lengths. A and B plus C is the sum of A times B and A times C. We're going to be using models to represent the distributive property. And some previous math content standard is from second grade geometry. So it's 2.G.1, which is recognizing and drawing shapes, having specified attributes like a number of angles or equal faces, and being able to identify triangles, quadrilaterals, hexagons, pentagons, and cubes. Now, some objectives for today include the following. So we're going to identify plane figures, understand concepts of area, apply formulas for area with respect to square measurements, decompose composite figures and find its area, and how to solve rectangular like grids using the distributive property. Now lesson introduction. So I will be playing a 2D shape song and an area cartoon song, and I'll transition into a partner activity, and I will essentially have students think where and what around us is a shape. And I have two examples to show. I have here a slinky and here a Rubik's Cube. So I will show the students that each face of this Rubik's Cube is a square. Everything is a square. And then this slinky, obviously it's not a 2D figure, because it's a 3D similar to the cube. But the face of one side is that of a circle, which is a plane figure. So it'll kind of have students engage with it and think, oh wow, the bottom of my water bottle is a circle. My eraser is a rectangle. For example, like that is a good way of connecting students. Okay. Now I want you guys to think of today's lesson like building on your knowledge. So the boat is what we already know about shapes, and the shipping containers we're just adding to it is concepts like area and square measurement or area measurement. Now some vocab includes the following. So we have square measurement, area, plane figures, distributive property, and composite figures. So square measurement are units used to measure area like square feet, and they're derived from multiplying length by width. Area is not a space within the inside of a shape and can be used using formulas or a grid. Plane figures is a flat geometric shape that has only 2 dimensions. And the distributive property is multiplying the sum of 2 or more addends by a number, and it will give the same result as multiplying each add individually by the number and then adding the products together. And then composite figures are figures that are composed of a variety of plane figures or 2D shapes. Alright, so I would like to pass out an area cheat sheet. You guys should have all received an area cheat sheet that looks just like this. Okay, I know it says perimeter as well, but we are not paying attention to that for this lesson. We are paying attention to solely area. So only this row, okay? Everybody just review it, okay? So now I'll be delivering my direct instruction. Okay. So some characteristics of plane figures are that they are composed of line segments that are connected to each other. To make a closed shape, they have only length and width dimensions. And then you will hear me often say plane figures and 2D shapes. Essentially, they are the same thing. Just keep that in mind as we go forward. Here are some plane figures. So we have a triangle, rhombus, square, circle, trapezoid, oval, octagon, hexagon, parallelogram, pentagon, and rectangle. And because earlier I showed a cartoon of 2D shapes, this should just be a refresher, okay? And you can see these examples on your area cheat sheet as well. Now, square measurement, right? So we know it's used to measure area like square feet, and we find it by multiplying length by width. And only when working with area do we use square measurements, okay? So like this example, we have 3 units, right? 1 meter square, 1 meter square, 1 meter square. So that it would be 3 square meters, right? Because it's only 1 by 3. So 3 times 1 is 3. This one, right, we know that there's 9, so it'll be 3 by 3. We multiply that, right? Area for a square is a square. So it'll be 3m times 3m, or 3 square, and it equals 9 meters square. And we say a 3 meter square, right? This is essentially a 3 meter square. Does anybody have any questions? No? Okay. Alright, and then area, right? As I mentioned before, the amount of space inside a plane figure. So like this image displays, we have a triangle here. It's colored inside, right? Colored inside shapes to represent area. And then we have formulas for area. You guys can follow along with your cheat sheet. So we have area of a triangle, 1/2 base times height, rhombus, base times height, square, a square. Area of a circle, pi times radius square. Trapezoid and rectangle is length times width, right? This is all just for area. Remember this, I will also write this on the board just to keep you guys refreshed. So we're identifying the shape, we're calling formula for the shape, plugging in the values, and then we get the final answer with respect to square measurement. So then we will go towards solving area for plane figures. So for this figure, right? So we know that this is a square. Number 1, it's a square. We got that. Then we use the formula. So we know it's a area equals a square. We got that. And then 3, plug in the values. So the only value we need for a square would be 5. As long as we have one side, we know the area. We don't need more than 1. So we plug in the values. So it would be area equals 5 square, or 5 times 5. And then our final answer, step 4, is 25 centimeters square. And then for this figure, step number 1, we know it's a triangle. And then we know that the formula is area equals 1/2 base times height. And then the values would be area equals 1/2, 6 times 4. And then we use PEMDAS, so parentheses is the first P. So we know that that's 24, so now it's area equals 1/2 times 24. And then the final answer is 12 inches square. And we're keeping in mind the square measurement. So then for this figure, we know like for step 1, it's a rectangle. We know its formula is area equals length times width. And then the values are 9 inches times 3 inches, length and width. And then the 4 is the final answer is 27 inches square. And then in solving the missing values, we're going to first identify the shape so we know it's a rectangle. The formula is length times width. We know the area is 28, so we'll put 28 over here. Equals, we know that 4 feet is the length, times width, which is our unknown. So then we'll divide each side by 4, and then our final answer would be width equals 7 feet. 7 feet would be here. And if you would tie it all together, we know that 7 times 4 equals 28. So essentially that would be our answer for that problem. I want you guys to use that same method like I did, okay? Now, for solving area of a composite figure, our first step would be to identify the shape. So we know that shape A is a rectangle and shape C is a square. And then the formulas for each of them. Rectangle is length times width, square is area equals A square. So we plug in the values for it. So for shape A would be 2 centimeters times 5 centimeters. So the total area for that would be 10 centimeters square. And then for square, it would just be 2 centimeters square, or 2 times 2 times 2. And then that total area is 4 centimeters square. So then our final one is to add both totals to get the final answer, of course with respect to square measurement. So then we'll add them both, 10 centimeters square plus 4 centimeters square, and our final total area will be 14 centimeters square. Working with rectangles and distributive property. So again, PEMDAS is mentioned. So multiplying a sum by a number is the same as multiplying each added by the number and then adding the products. So we can see the x moving to a plus b, right? So it's 6a. XA and xb, so equals ax plus bx. So in here, right, we're kind of dividing this. So we know that it would be 2, right, by 8. So that would be 16 here. But you can simplify it and still keep, right, the 2 sets. But here we have 8 circles, but 6 of them are different color and the other 2 are different. So we'll put 2 because of the 2 different colors, plus 6 because of these 6 different circles in a different color. And if you were to put arrows similar to this one, it would solve the parentheses first, that would be 8. Then you would get 2 times 8. Or you could use the arrows, right? So it would be 4 plus 12, and they would both equal 16, which is what we get over here. So essentially there are multiple ways to find this, and the distributive property is a much faster way of getting the answer. So you need to keep that in mind as we go forward. So some standards that I met today were recognizing area and concepts of area measurement, counting unit squares, relating area to multiplication and addition, right? Finding area by tiling, multiplying side lengths, and using the distributive property, and finding the area of a rectangle. Okay. And then we'll go into some guided practice. So I will be passing out a worksheet that looks just like this, along with some graph paper. You guys all should have received a copy just like this. We'll be working on this together. Alright, and then we'll have a review and questions if students have any. And then essentially everybody should have the same answers. Let me see here. And then as part of this, I will also include a problem on the distributed property. So I'll have students on their graph paper make like a problem with me, and we will break it up together. Considering I kind of want to just keep this on the board, I could probably try to make a problem here. So it'll look something like this, right? So we're just breaking apart the graph and using the distributive property to solve it. Just a quick overview of that. Okay. So we'll move forward with independent practice. I'll be passing around some worksheets. So you guys should have all received these two worksheets. For this one in specific, I'd like for you guys just to focus on rectangles, squares, and triangles. If time permits, I would like for you guys to work on the circles, but you guys do need to use a scientific calculator. So I would suggest doing some research, finding the scientific calculator website, and using that to solve for area of a circle. And just remember the steps again. Right, I still have it here on the whiteboard for you guys to reference to. I'll give you guys a timer of 10 minutes. If you guys go over that, that's fine. And once again, you're more than welcome to work with your peers to solve for these problems. I'll be walking around and asking if you guys need any help or any kind of questions, and I'm there to help you. And I'll be playing some tranquil music as well. It helps me focus. Also, one resource I forgot to mention, I will also be stapling graph paper to each of these, just for you guys to work it out. I know I like to work out things on paper, so it'll become very useful. So then we'll have a review and questions. I will pick a few sticks from my popsicle stick bag, right? Okay, what did you guys do for this problem? How did you get that? Did you use the answering process? Okay, and then I'll also be there to support for students who need questions, or sorry, who have questions, right? Then we'll move forward and just go over the answers once again. And then formal assessment. So you guys should have all received a paper that looks just like this. I will be playing some tranquil music. I would prefer if you guys keep your voices to a low level, and truly think about it and work on it, each of them, really appreciate this, you know. I'll be walking around to support students and answering questions as well. So we'll do a quick review. I'll be using my popsicle sticks, and since there are about maybe 4 to 5 problems, I'll be choosing 4 to 5 different sticks, and I'll be taking them out so everybody has an equal and fair chance. Once that's done, I will show the answers once we review it, of course. And then just to reiterate the state standards, right? Recognizing area and concepts of area measurement, counting unit squares, relating area to the operations of multiplication and addition, finding the area of a rectangle, multiplying the side lengths, and then using the distributive property to find those answers as well. Okay. Then the objectives met today were identifying plane figures, understanding the concepts of area, applying the formulas for it and with respect to square measurement, decomposing composite figures and finding its area, and solving grids using the distributive property, which is something that we did here in the guided practice. Okay. Now some jokes. What do geometry teachers have on their floors? Area rugs. What do you get when you cross geometry with McDonald's? A plain cheeseburger. And then why doesn't anybody talk to circles? Because there's no point, right? Because, circle, right? A circle. There's no point, okay, Slightly silly. Okay. And then closure. So I'm picking on about 2 or 3 students just to make sure that everybody has a good understanding of today's lesson. So I'll say, okay, so today we learned how to use, that kind of gist. Okay, now our next slide. So our game, so I'll be dividing the class into 3 sections. So it's 3 different rounds of 3 different students, and they get to create their own names. I will display the problems. One student from each section comes to the board. My board here, of course it'll be blank and a lot bigger. And they can't use the reference sheet, but they can use their group's assistance. And students have about 45 seconds to a minute to complete this. And once one student is done and their work is correct, they win that round. Only when all of their work is correct can they win. If there's a tie, all groups get 1 tally. The group that has the most tallies wins the prize, which is something as fun as Cookie for Choose. Okay, so then here are some example problems. Once again, reiterating the answering process, just to kind of refresh that. Of course, they have to answer all these questions, right? Again, the same process. And then write the same question, same process. So that'll be about 3 minutes, right? A minute around. And then essentially that is it, right? I'm sorry, let's go back. So once the group that has the most tallies wins, essentially they get the candy. And I'll kind of call it a day of, the end of the lesson there. And essentially I just want to reiterate and say great job to everybody. You guys all did fantastic with that throughout my instruction, the practice, the independent practice, the assessment, and trying your best at the game, It's all just testing your skills, and I essentially hope you guys enjoyed the lesson. And I'll be conducting another one soon. Thank you, and have a great rest of your day.